How's it going, everybody? And welcome to another installment of Whiteboard Wednesday. Hope everybody's doing well. We will get started here in just a few minutes. I'm working on building out a lab of sorts to walk through some capabilities that are out there and testing the waters to see what exactly it is that I want to go out and do demos on as we work through all of the workbooks that I've got ideas to develop for. So I'm actually really looking forward to doing this type of work and seeing how it all shakes out. So we'll get down to it here in a couple of minutes. I want to give everybody a few minutes to get started, be able to join the live stream and all that good stuff that goes with it and all that type of stuff. If at any point in time you guys have questions on what I'm building or the direction I'm trying to go with something, feel free to drop a comment in the chat. I'll be happy to try to answer those questions and things like that. But the goal here is to try to help those of you out there that are at different stages of your career when it comes to networking and technology, understand how stuff works and, you know, design from both the physical, the logical, why you would go one way versus another, you know, stuff like that. Try to help pave that path if you don't already have a solid understanding with it. So, and I'll talk about the topologies that I'm building out right now and how you would go about putting something together like this and some of the configs behind it and things like that. Huh. What's up, Rob? How goes it, sir? So, we have trying to keep things interesting as we progress through all the stuff that we're going through here on our Whiteboard Wednesday series. So yeah, I'm going to finish doing the cabling. This does take a little bit of time to do, but once we get through it, we'll talk a little bit about some the couple topologies we have here. I'm always, like I said, I'm always working on some sort of thing, trying to either learn something new or trying to, you know, test out a new feature, stuff like that. So, good stuff. Well, I'm about to get into what we're doing today here in just a minute. So, give me another 30 seconds to finish doing the cabling here, and that does take a minute. So, what we're going to do today is we're going to take this lab right here, and we are going to, at least the expectation, my intention, is to show you guys what it would look like to deploy a highly available internet edge with Palo. So it's it takes a little bit of doing, but we're going to walk through how to get everything stood up, get the firewalls stood up, get them configured, all that type of thing, all that type of stuff. So it's a little bit of doing, but you know, just to try to widen everybody's horizons and not be all Cisco focused and understand that there's more than one vendor out there. So what we're going to do is the top half of this box right here is going to be the public side, and the bottom box will be our private side. So we'll have some IP addressing that we'll have to do and things like that to try to organize everything that we're doing. We have the firewalls to get stood up. We have a bunch of switches in the middle connecting everything together that we have to provide connectivity to. We have our internet edge that we're going to be connecting to. We have some BGP peerings that we're going to be standing up. And I'm going to walk you through how I actually stood a customer environment up, very, very similar to this, almost identically. Slightly different hardware and a slightly different design. They were using chassis aggregation through Cisco StackWise. I can't really do that here. So we're going to get it as close as we can. But the intention here is to get the firewalls up, get the peerings up, and all that stuff that goes along with it. So with that being said, we're going to go ahead and dive into that. So I'm not going to, if you guys have questions, for those of you that are watching, if you guys have questions about anything that I'm doing at any point in time, feel free to throw that in the chat. I will be happy to try to answer whatever questions you guys have, try to provide a little bit of insight. If you're stuck on something, you don't understand why you would do a particular thing, let me know. And I will do my best to try to answer those questions and so on and so forth. So with that being said, I'm going to go ahead and pull up Secure CRT. I've closed out. I have this one that's not connected to anything, and we're going to use that to get everything up and running. I'm going to start with the firewalls first, just because they take some time to get stood up. So we're going to go ahead and do that. I'm going to go ahead and I'm going to edit these guys real quick just to make sure that they are going to use telnet connections to connect into the firewalls. And then we'll get all that stuff going. All right, so I'm going to go ahead. I'm going to start this guy up here. And assuming that I've done my job correctly, there it goes. So our goal here is to get the firewall stood up, get them squared away so that we can log into the firewalls through the GUI, and we can do an initial configuration on the Palos, get the Palos initially configured, do a little bit of routing, default route, that type of stuff. We'll get the switches going as well. The firewalls take a little bit to get going, but once they're stood up and they're working, the switches don't take very much to get online, and neither do the routers. So we're going to go through and get that process started, and we'll do some basic BGP up here at the top. We'll do a little bit of HSRP between the routers so that the Palos, when they're in high availability mode and active standby, their default gateway will point to the HSRP virtual IP address, the VIP, so that no matter which guy's actually the forwarder, it doesn't matter. We point to the IP. There'd be some reconvergence through spanning tree and things like that if you needed to, stuff like that. So it's good stuff. So we're gonna let that continue to do its thing. You're a noob and want to purchase any class you're teaching, selling for 200-301 through CCIE. You're the best. Oh, I appreciate that, man. I will be doing some content for CCNA. Right now, I am most of the way through my CCNP Encore and a NARCI workbook. I'm wrapping up that configuration here very, very soon. And once that's done and the video series for that is complete, I will probably, my goal is to get that done before I go to Cisco Live. That's my intention. So I've been putting a lot of time and effort into that. Once that's done and the video series for both the deployment and the troubleshooting sections are complete, and all that has been released to Patreon and is accessible, then I'm going to circle back and I'm going to do the CCNA stuff. I have, I'll be taking the CCNA blueprint, and I'll be walking through, how to configure a lot of stuff that's on the blueprint. There'll be lab-specific packet tracers where you're going to have specific configs that you'll have to do, and it'll break it all down for you and that type of stuff. So I have a lot of, and then a video series that's going to go along with that. That's going to walk you through how to do all that stuff through CCNA. So you'll have a landing point with CCNA that you'll be able to kind of jump into, go through. You'll get, you'll be able to ask questions and stuff like that and get feedback for all those type of things, and then be able to work your way up to CCNP. Because I remember going through my CCNA, and this is like 15, 16 years ago, of how do I get there, right? I really struggled with getting my CCNA. So, and it looks like it's only gotten more difficult since I got it. So it's one of those things where I get it. It's a challenge. My goal is to try to make the learning process as simple as possible and easy to understand. Not overly simplify it, right? Because I don't want to take something and dumb it down to where it's, it's overly simplified, because sometimes you miss things if you overly simplify stuff. So it's more, the best way I could describe what my goal is with everything that I go through when it comes to how I plan on, with the content that I'm planning on releasing, is how my jiu-jitsu instructor talks about it. And he always talks about how he wants to give a black belt level details to white and blue belts so that they can progress themselves through their jiu-jitsu journey. And so I really like that analogy, because I'm trying to give you CCIE level detail on topics that you're going to be seeing on the CCNA blueprint. So it'll be a thorough walkthrough of a particular technology so you understand it. So it takes time, though, because that material is not easy to cover all the time. So, and put it into very easy to understand terms. So hopefully that'll work out. I'm going to go ahead and boot the other firewall here while we're waiting, just so we can get that process started. So I do appreciate the vote of confidence from you. That's always good to hear and good to see. So while those two are booting up, I'm going to go ahead and knock out the other switches here, just so that we can get some of the other configuration, the process started here. Do you mind teaching using GNS3 versus Packet Tracer? Isn't more realistic in the field? So you're right. GNS3 is more realistic, but the only reason I was going to start with Packet Tracer for like CCNA and the lower level certifications is it's free, and I can build a lab inside of Packet Tracer and save it as is. It's almost like sharing you can make the lab specific. So if somebody doesn't know how to create a VLAN on a switch, there will be a specific lab for that, and if they're not sure what they're doing, there will be a detailed breakdown of how to do that, and they'll be able to look at the reference, like, okay, before and after, and they'll be able to compare and contrast. So that's what I'm planning on doing. There's not going to be a ton of packet tracers, to be honest with you, because there's only, if I had to guess, 10 or 12 real configuration steps on the blueprint for CCNA. The rest of it's all conceptual. So when you pivot out of that and you go into the Encore and an RC series, that's going to get much more into the weeds. And so that's kind of the gist there for it. But my goal is to definitely try to make it easy for you. Now, since we're talking about labs and whatnot, you'll notice that I did boot switch 19, and it did come up, right? But notice that switch 19, it went from blue to gray. And this is something that I have to deal with on a semi-regular basis, where I have to close something out and I have to boot the box back up, and it gets into a kind of a boot loop. It kind of sucks, to be honest with you. And then when you do that, it bugs out. It doesn't want to launch for you, so you have to monkey with it a little bit. So I do believe that I need to reboot this server. And then once the server itself needs to be rebooted, and that usually fixes any of the Eve issues that I run into. But I don't reboot them very often, because I'm usually working on something. So, but hopefully switch 19 will stay booted. And then what I'm waiting for now is the DHCP process to kick in to give me IP addresses to PA17 and PA18. So I will focus on that here in just a minute. Once I get switch 19 up, we'll go ahead, and I'm waiting for switch Palo 18 to get an IP address so that we can go ahead and start logging into it and getting it base configured. So we'll start off with this guy here. So usually when you get DHCP for the management IP, you're in pretty good shape. So I'm going to go ahead and type in admin and then admin again. And this is going to prompt me to change my password. So enter the old password, which is going to be admin again, and then you'll type in the password. I'm just going to use capital P @ SSW0RD, and repeat that because it's a lab and I don't care. So once we have that in place, we'll be able to log into the firewall through the CLI. And the configuration for the Palo isn't very difficult. It's just a matter of going through the steps. And I've done enough of them to where I've got a config sync here for what I'm trying to do. So what we're going to do is you can pre-configure it if you'd like. And so I'm just going to go ahead and I'm going to give this guy .80. I'll do 81. And the host name will be, we'll say PA17. There's another comment. Check the number of vCPUs allocated to the image. The Cat AK and some of the bigger images need more RAM CPU allocated to stop boot loops. Yeah, I don't have any Cat AKs in this particular lab, but you're right. It's definitely an issue if you're digging into it in that respect, but for sure. So I'm going to go ahead and type in configure, and then I'll copy and paste this config in like so. And I don't think 81 is in use in my lab. I should be okay with that. Yeah. So another thing too is I don't have EVG. Go ahead and paste that in like so. Commit force. I don't have EVG running as a virtual machine inside of ESXi. The EVG instances I have running right now are both bare metal installs on Dell R810 servers. So I don't really have that flexibility to do that. But if you're if you want to do that, that's completely up to you. But I do agree with you. You do have to bump up the virtual machine to have more resources if you want to run bigger images. So I'm going to log in to PA18 and get him squared away. And then PA17 should be, we're waiting for him to do his thing. He might not be fully booted either. You'll notice that the more dots you have, the longer is an indication that you haven't given the firewall enough time to boot. So we'll go ahead and configure, and then I'm going to jump back over here to this guy, and we'll give this guy here 82. And then we'll take all this config right here and paste it in and commit force. So this number, these dots will go away, and oh, you meant to the actual iOS node. Yeah, that too. I take the default because these are just iOS V images. They only take like 1 CPU and a gig of RAM, I think. So it's nothing significant. It's just kind of a pain in the butt every once in a while. The image doesn't boot correctly, but you know it is what it is. I don't let it bug me too much. Now I'm just waiting for the firewalls to finish doing their commits, and then we'll be able to get into the rest of it. But you're right, that is definitely something you can deal with. The Nexus is one of those things where it's if you've got the most updated versions of EVG, a lot of the times it comes with the basics or the base allocations already preset for you. So that one's still taking its time. These firewalls weren't quite ready to boot yet, so that's why they're taking a while, but that's okay. That booted quite nicely, so we're going to be good to go there. So I'm just going to go ahead, and while I'm waiting for PA17 and 18 to finish, I'll go ahead and finish getting these devices up and running. Shouldn't take very long at all, honestly. Oh, there it goes. So when you normally these numbers the percentage complete will be much earlier in the process. So I'm just waiting for both firewalls to get where they need to be, and we'll be in good shape here momentarily. But this is the some of the time-consuming stuff where you're waiting for devices to boot and all that good stuff that goes along with building a lab. It can be kind of a pain, but it is it is par for the course in some cases. So I'll get some of this other stuff going here. PA18 is almost there. Okay, so now we have an IP address set on PA17. I should be able to log in if I go to HTTPS. I should get a prompt to log into the Palo. That's a good sign. We're going to use admin and then the password. And okay, so whenever you see this, it's just one of those things where for some reason the CLI config hasn't triggered over. And it's going to tell me to update my password. So the old password is going to be admin. And the new password, I just use password. And then we'll log in as admin. And for a lab, it gets the job done. There we go. We'll close that guy out. All right, so at least we're cooking with fire now. We're able to log into the firewall. We're just going to go no, do not show again across the board. And knock that out. We are running a 9 code, which is a little bit older, but it still gets the job done. So if we come back to our topology, we have we've got Palo 17 and switch 19. So E1/2 and gig 0/0 have a subnet. So for the sake of getting this knocked out pretty quick on switch 19, I'll log in and we'll go to interface gig 0/0. I'll type in no switch port, and then I will set the IP address to be IP address of 10.17.19.19/24, and then I'll give it a host name of switch 19, and then I'm going to go over to PA17 on E1/2. We'll go to network, then we'll go to interfaces, we'll go to E1/2, and actually let me go ahead and get out of the way so you guys have a little more screen real estate. There we go. And we'll convert this guy to a layer 3 interface. And we will set the virtual router to be the default VR. And then we'll create a new zone to be inside. And then we're going to click on OK. The IP address here will be, we'll add a static address. This will be a 10.17.19.17/24. Click on OK. So I'm just going to go ahead and commit that right away, just because the fact that it's, I want to have at least the config starting to apply, and we'll pull back up on secure CRT. The default for the VIOS is 1 CPU, but if you increase it to 2 CPU, they work much better. Oh, okay. I've never actually messed with the counts, so I'll have to check that out. All right, so the configuration applied correctly there. So now I just want to make sure it's going to work. So do ping 10.17.19.17, or I'm sorry, I had to do it from this side. So I'm on the, because I don't have an interface profile. So actually, let me go knock out that real quick. If you go to interface management, under network profiles, we'll add an interface profile. We'll just call int prof, and then we'll allow ping. I forgot to do that. I'm going to click on OK, and then I'll go back over here to interfaces, and then E1/2. Underneath the advanced tab, you can pull the management profile of int prof and apply that, and that will allow it to send and receive pings. So just a little side note there. It's a little bit of a pain to go through that, but it is what it is, because then we'll be able to ping the firewall directly from the switch. We won't have to ping directly from the firewall, which I can still do. I can go to here, I can say exit, and I can see ping host 10.17.19.19, and hopefully it responds. So this is the one thing that I've been running into issues with. This is where I think the server needs a reboot. Is no matter how many times I've tried to rebuild a lab, the pings do not work. So that's one of the things that's kind of a drag when you're trying to set them up. So I might be forced to just reboot the server because of the issues that I'm running into there. So there's not a lot running on this guy. I have a couple of other things that I could do. So while I think I'm going to go ahead and just reboot it because it only takes like 5 minutes for it to reboot and come back online. So in the meantime, I'll go ahead and we can talk about something else in the short term. So to do that, I'm just going to go ahead and power PA18 has been configured, and he is squared away. Okay, configuration committed successfully. Good. So I'm going to go ahead and log into that IP address real quick. And we'll do a 10.255.1.82 just so I can get the admin portion of this done. And then it should prompt for a password change. Okay. And then we'll log in as admin and then the password. Okay, cool. Now that I've done that, I'll go back to my lab over here. And I'm just going to highlight all this stuff. And I will stop selected. And do the same thing over here. Give that a moment to do its thing. And while we wait for it to reboot, and I'll show you guys how to do that real quick. It actually doesn't take very much time at all. So remember, this is a bare metal install of EVG. So I have to go to the server level to do the reboot. And so I've already got this already built into my session manager. So I'll just double click here on this box. It'll allow me to log in, and but it says system restart required. So I'm just going to go ahead and type in reboot, and the server will begin doing its reboot. It takes probably 5 to 7 minutes to come back online. So what I'm going to do is I'm going to send a consistent ping to ping that IP, and then when it starts to respond, we should be good to go. So I'll just shift my focus for a few minutes, and we'll go through some other stuff. So one of the things that I also see a lot, we'll pivot a little bit to back over here to the topology. This is the Encore and a NARCI workbook topology. And what we're essentially doing in the other lab that we're focusing on was focusing on the internet edge. So because the Encore and NARCI blueprints focus on iOS routers, which is both of these are iOS routers, I've enabled NAT on these devices so that if I'm, say, PC 10, I should be able to reach the internet. So because of the fact that I am just today, I was able to finish up the majority of the configuration and get that all squared away. So you guys are kind of in for a treat right now. We're going to walk through some verification steps. So what I'm going to do is I'm going to pull up E1 here, E1 and E2. E1 is my default network exit point. So that's the edge device that I'm actually expecting traffic to leave out of. And so I'm going to pull up my other secure CRT session, which is going to be all my PCs. Because like I said, this is a really, really big topology. So what I'm going to do is I'm going to grab, it's down here at the bottom, I'm going to grab PC1, for example, and on PC1, the bottom, I'm going to verify that I have an IP address by a show IP interface brief. And If anybody's not sure how I'm doing this, I've just given the router a desktop icon in Eve so that it looks like a PC. And I'm going to try to ping quad 8. And I can reach it. If I come over here and I do a show IP NAT translations, I have a translation in my NAT table. Now if I try to trace route to it, I should be able to reach it. And it gets out to the internet. So it does take the path that I expected to do. Now I've already verified PC1 and PC2, so let's take a look at some other devices that we would need to look at. Let's take a look at PC9, and we see it's got an IP address, and we're going to ping quad 8. And it is not getting there. Do we see the traffic coming in? Okay, we see a try-in, right? 5.10.11, but for whatever reason, the server just started responding to pings again. But the pings are not going through. So let's go ahead and do a trace route to the same IP and see how far we get. So we hit our gateway. We hit our gateway and we die. Okay, so we'll do a little bit of impromptu troubleshooting. So we're going to let this ping continue to go. If our gateway is D5, and we can verify that here. I'm on D5, and I do a show IP interface brief, right? I have the IP address, and if I do a show IP route, I have a default route pointing to 10.151. So the traffic should go via C1, and I have an E1 default route going out online. So routing table looks correct, right? So let's take it a step further. So we need to figure out why it's not going outbound. So let's just do a reverse ping 10.5.10.11. 10.5.10.11. Okay, we can ping that. So we have gateway to the endpoint has reachability. But let's go to core 1. And we're going to do a show IP route. And do we have a 10.5.10? Oh, okay, so we didn't have a 10.5.10 in here. So what could be our possible issue here? So we don't have a 10.5.10, we don't have a 10.5.11. So what's wrong at the moment? Well, the thing that's wrong is that, remember, routing is bidirectional, no matter where you are in the network. Unless you're NATing from private to public, that's a little bit different. You still need end-to-end connectivity, but you're translating your IP address. In this case here, we're not doing that, but 10.5.10 and 10.5.11 are not being learned by core 1. And that makes total sense why the trace route is dying. So if we look at how we're doing things on D5, let's do a show run section, or do a show IP OSPF interface brief. And we can see that VLAN 10 and VLAN 11 are both enabled to, they're both enabled for OSPF, which is what we want. And one is in area 5, the other one is in area 6, respectively. So what's the deal? How come that's not working? Well, the other thing that we can look at is, let's look at core 1 again and do a show IP OSPF database. And we are looking for area 5 and 6. Well, we have area 0 sitting over here inside of the core, but then we have area 135 is connecting us to area 5 and 6 with the intention of using virtual links, right? And that's what's set up. Now, if we look at how this is set up, if we look through here, we don't see, well, we see that sitting right here, right? So the subnets are actually sitting in place. So they're in the database. on core 1, but they're not in the routing table. So this is the first thing you want to check, is validating that the subnet you're trying to learn is in the database. They're in the database, and for area 135. So that's a good sign, right? The database flooding has occurred, but they're not in the routing table. Show IP route for 10.5.10.0. It sees it, but it's encompassed by a /8 routing entry. And why is that encompassed by a summary route? So if we look at show IP route, we see it incorporated here via 10.1.2. So the question is, how do we, where's this come from, right? So what's happening? Well, what's happening is that core 1 is getting a summary route, an external type 2 route from what? From core 2. Core 2 is getting the route, but because he's getting the route, core 1 doesn't have a more specific route to send it, so it's going to send it, technically it's going the right direction, right? But it should have a longer match, meaning it should have a 10.5.10 and a 10.5.11 in the routing table, and it doesn't. So I know what the problem is, I know what's triggering this, but it's more or less walking through the logic. So let's take a look at C2. Do a show IP route. We have a 10/8 here, but we don't have a 10.5.10 or a 10.5.11 sitting here, which is where it should show up. So what's the next thing to take a look at? Well, we got to track down where that route is being originated from. So in the interest of time, since this was never meant to be a troubleshooting live stream, what is coming into play now is on D6. That's the next time. If we look at C2, we're learning that 10/8 from 10.266, which is D6. And if we do a show IP route, we have this N2 route. Now, where this is coming from E2. Now, what's happening is, in order for DMVPN to summarize some of the specific routes, I'm doing a summary route on E2. Here, we look at show run interface tunnel 100. I'm doing 3 EIGRP summary routes. That's where that route is coming from. Now, it's interesting because if I get rid of that prefix, if I got rid of that summary address, do you think that's going to fix my routing issue? Well, let's try, because it's a lab, right? I don't care if I break it. I just need to figure out why something is working the way that it is. So I'm going to go ahead, I'm going to pull out this summary route and see if that doesn't resolve my routing issue in the core. So that's going to resync all of my spokes, and then I'm going to go back over here to core 1. I'm going to hit the up arrow, do a show IP route, and if we go through, my 10/8 route is now gone, right? The question is, can I ping quad 8? No, still can't reach it, right? So we still have a problem. So it wasn't a routing issue in that from E2 inbound to core 1. That's not where the issue existed. And we can filter that, but I'm not going to dig into that right now. What we have is a interesting scenario where we have D5 is advertising the route, because if we look here, show IP route, we see it'll show up locally because it's locally connected, right? We see these two subnets right here, and if we do a show IP OSPF interface brief, we can see that both, what do you call it? Both VLANs are enabled for OSPF. That's the first thing you would want to check. Now, what's interesting is that we run into some issues here because Virtual Link 1 is up. The one to... We actually have Virtual Link 2. We should have... Yeah, there should only be 2 of them here. Not sure why. The 1 to 3 is up. Let me move this over here just a little bit. So we have technically 3 virtual links showing up. We have this one going to router 1, which is working. Actually, yeah, we have a small problem there. So it's an extension of the control plane, right? So it's a point-to-point connection in order to bridge area 0 over area 135. So if we're looking at the routing table, we clearly see that we're learning routes. We even have a default route, right? But core 1 doesn't see the routes coming across. So if we do a show IP OSPF interface brief, we should have virtual link 0 is up, but there are no neighbors connected or formed. But if we look right here, we see that gig 1/0 connects down to D5 and the route's coming across. I'm sorry, the OSPF adjacency is up. If we do a show IP OSPF neighbor, we have a peering to router 5 respectively. So that does work. And the same thing on D5, we have an OSPF adjacency or neighbor. We have 2 adjacencies with 1 and with 3. So it's an interesting scenario because off the top of my head, I don't know what's broken. So this is one of those scenarios where I'm like, I wasn't anticipating this, so I'm going to have to dig in to figure out why the route isn't propagating and dig into that. So off the top of my head, I don't know what's broken. I was like, I don't think the summary route would do it, but it is giving me a 10/8 route, which is interesting. Now, the part that's a little bit even more interesting, if we look at, on C1, if we look at the database again, we see that 10/5/10 route for area 135, these guys, they are coming through. So if we look at that specifically I'm looking for the advertising router of 10.0.0.5, and we see what's being advertised. The 2 subnets are coming across, and they look correct. But if I look at not the advertising router, I want to look at the summary. The link ID is what I'm actually looking for. That's the network summary? Yeah, the summary. So I want the summary and the link state ID, so 10.5.10.0. So the upward bit is set. It's coming across, but why it's not allowing the route to the OSPF database is advertising it from D5 to C1, but here's an interesting thing. If we do a show run section OSPF, one of the things we have right here is we're doing MD5 authentication over the virtual link, so I may have to flap it. And I'm trying to think back if there's a caveat if you enable authentication that the virtual links have to be bounced. So what I'm going to do, just because of the fact that it's a lab and I'm not too worried about stability, I'm going to do a clear IP OSPF process, and we'll just clear it for C1 into C3. So it makes it a little bit interesting to see exactly how this is going to come through. So I don't know if that's going to fix the problem or not, but for the simple fact, for this, what we're trying to do, it might do the job. Yeah, I didn't think it would. I still don't see the routes. So I will have to dig into that. I'm not exactly sure why that's the problem. So in the interest of time, and because of the fact that I want to continue moving this along, I'm going to shift my focus away from this area because now that I know about it, I'm going to have to dig into it. Well, let's look at PC5 and see if we can ping from there. So we're going to ping quad 8. PC5 is slow. What about PC6? Do we show IP interface brief? I do have an IP address. Yep, it's got an IP address. Show IP route. Let's ping my gateway, 10.34.11.1. Okay, so PC5, there's other issues in the network that I have to resolve. So we will, I'll dig into that. Let's see if PC7 is any different. Ping quad 8 from this guy. Okay, he is also giving me a hard time. So what we're going to do is show IP route. We'll ping 10.34.11.1. Some of these situations that I'm running into here are usually pretty easy to fix if I save the config and I just reboot specific devices in the topology. So other times it requires a whole reboot of the server. So that could be kind of a pain. So that's essentially what's happening here. So with that being said, I'm going to go ahead and pivot because I've got the flexibility to do so, and I'll come back to these issues and I'll work on figuring them out. And when I go to do the video series for the Encore and RC series, I will point out issues that I ran into and times that I had to reboot stuff to fix them and things like that. So if I come back over here to Eve and we log back in on this side, the firewalls, go ahead and dark mode it up here. We're going to go ahead back over to this side here and we'll focus on getting these devices back online. It shouldn't take very long at all. I will get Palo 17 started and we'll do Palo 18 and then we'll knock them out. So now that I don't have anything going on, these things, they tend to boot just a little bit quicker. And we'll focus on getting all this other stuff squared away. I don't know why Firefox does that, but it does. And I'm not a big fan of it. It like refreshes randomly. And I'm like, why? Kind of annoying, to be honest with you, but it is what it is. So, and then we'll go ahead and get 21 started. These devices boot up pretty quick when you do a fresh reboot of the server. The boot up speed is pretty quick. And they're lighter images, so they usually boot up pretty fast. So definitely makes life real simple when you do that. So we'll see where we're at with the Palos. They should be up pretty quick, considering. And then once they are, we'll go ahead and on switch 19, I'll go ahead and I'll get him reconfigured real quick. And Palo should be up here momentarily. They've got their IP addresses back, which is good. So, oh, did I give this guy the wrong host name? I did. That's okay. I can fix that pretty easily. So we'll go to Palo 17 and we'll refresh it. They may not be fully booted up yet. That's what I thought. They're not fully booted up yet. That's okay though. So I will go ahead and knock out the IP addressing real quick for 20 as well. And we'll go back to 19, and then we'll do interface range gig 0/1 through 2. We'll do a switch port trunk and cat.1q switch port mode of trunk. And we'll do a channel protocol as LACP channel group 1 mode active, and we'll get LACP working between these two. And interface range again. Just like that. We should have a port channel between those two here momentarily. And then we will wait for 17 and 18 to finish booting. There's our port channel. That's what we wanted. And then on 21 and 22, we're gonna do something a little bit differently. We have to do trunk links everywhere. Actually, we won't do trunks. We'll do access ports, and we'll put them in Spanish report fast mode, because 25 and 26 will be doing HSRP. So we'll go ahead and just get them booted up real quick. Hopefully they boot up pretty fast. Hopefully. And then we'll go ahead and by that time the firewalls will be, there we go. And then we'll do the same thing here, 82. That's what we're looking for. And then what I'm going to do is come back over here to our topology, and we're waiting for, bring start 26, bringing that up. Just like that. Okay. So what I'm going to do now is we technically don't need to do anything on 21 and 22 unless we want the port channel to be up and running. So that would be the only other thing we'd have to worry about. But if we don't do anything with it, which is fine if we don't, they're running just a default configuration. So VLAN 1, this will be a port. It should start to learn stuff. But the first thing that I want to do on PA17 is check the interfaces, and it does have an interface profile. So I'm going to go back to 19, and I'm going to do a quick do ping 10.17.19.17 and see if it responds. Okay, good. So the ping responds, which is what I was looking for. So if that responds, then I know everything else that I plan on doing should come through pretty easily. So what I'll do is on PA, this guy here, I'll do the same thing. I just have to make a couple of quick adjustments. Click on close. We'll go to device, and we'll go to, this will be PA18. Click on OK there. And then we'll go to network. We'll go to E1/2. Actually, let me do the interface profile real quick since I'm right here. We'll create one. And then it'll be a ping. And then we'll go to interfaces, E1/2. We'll convert to layer 3. And let me turn this off. It'll be easier to see. We'll set the virtual router to the default virtual router. Security zone we'll create one. This will be inside. We'll click OK there. IP address here will be 10.18.20.18/24. Actually, I need to do one additional step. Advanced, and then we'll grab interface profile, and then we're going to go ahead and commit that. That should go by pretty quick. And then once we're there, then we'll be able to, once it pushes the config through, I'll be able to refresh, and then the Firefox tab will reflect the actual host name. We'll give that a moment. And then I'm just going to go ahead and refresh. And then Palo 18 is what it should show up now, which is what it is. All right, so now that we've done that, I should be able to go to switch 20. No worries, Brendan. Do show IP interface brief. Do ping 10.18.20.18. Should ARP. And then we should get a ping reply back. All right, so the next thing I have to go do is go back over the topology. Let me turn light mode off. We have to come in here, and I'm going to add a little bit of, actually, let me get rid of that. And I'll show you some tricks here. Let me go ahead and get out of the way. I'm going to right click here. I'm going to go to edit style, and I'm going to give it a link label. This will be 10.17.19.0/24. Do the same thing over here. We'll do a 10.18.20.0/24. And then in between E11, we'll come in here and do, this will be a 10.17.18.0/24. And E11 will be our high availability link. And so what I'll do is on PA17 on E11, when we go to do high availability, which I believe is underneath the device. Okay, over here under high availability, we're going to say enable HA group 1, and then the peer HA1 IP will be 10.17.18.18, and we're going to click on OK. And then we're going to select this port here. I believe we can move it to, okay, I think, yeah, that's right. Over to network on interfaces, we can take this and we can make that a type of HA. I'm using secure CRT. That's what I use for using SSH. Well, the same thing, add Palo 18. Move this to be HA. So then underneath device and then high availability, we will change this one here to be E11. And we'll click on OK there. Same thing here under the device, high availability. We will enable it. Group 1, and then this one here will be 10.17.18.17. And we will change this guy here to be E1/1. And I think that's all we have to do, because I don't have any additional ports to do any of the high availability stuff. I'm going to go ahead and commit here to get HA up and working. And I'll do the same thing on 18 once 17's config has been pushed. Because what's cool about Palo is if you did something wrong, it'll squawk at you. It'll tell you down here, hey, you did this, and it says, okay, here we go. So high availability HA1 interface configuration requires an IP address to be to be configured. Yep, okay, so I have to come back over here to this guy, and I have to set an IP address. So this one here will be 10.17.18.17 slash, and the max will be /24. And then we'll click on OK. And the same thing on this guy here. It's been a little while since I've done it, so I don't remember exactly how to configure it, but I figure if you make a mistake with security or with Palo, it'll let you know. So we'll try to commit that again. Assuming I did everything correctly this time. High availability state synchronization. Oh, that's right. Gotta turn that off. We're gonna say nope on that one. And the same thing here. We technically could use the same interface, I suppose. It's been a while since I've done it, but and really all you'd have to do is you'd have to put more links between the devices in order for that type of stuff to work. So hopefully I've done everything right up to this point. Okay, I feel like I'm going down the right direction now. Although you would want to enable session synchronization between your devices so that if there's a failure in the network, then you'd be good to go. I'm going to go ahead and commit that change here as well. So we should have HA set up here momentarily. Now, while I'm doing that, I'm going to come back over here to the dashboard. And if you notice, there's no indication on the dashboard that HA is not set up. So we want to add that in. And you can come down here to widgets, and you go to system, and you go to high availability. And it'll be there. And now we're just waiting for this side to do its thing too. And we're going to close that out. We're going to go to dashboard. We're going to go to widgets, system, and then high availability. And it looks like we're looking pretty good now. We're going to refresh. That's good. So the other thing we're going to do is we're going to add a widget system, and then we're going to say interfaces so we can see what's going on here. All right, so now that we've got that, it says HA initializing. So we're going to go ahead and, okay, cool. So what we want to do is, this guy here is the local is the active. We're going to go ahead and say sync to peer. So now it's going to push all the config over to Palo 18. And so his configuration changes will take effect. Now, what's interesting about this is, now if we go back over here to our topology, you'll notice that this IP address right here, this will have to go away. So there will be some interesting pieces there that I actually overlooked when I was setting this lab up. But the communication back and forth, E13 on both devices will share the same IP address. So it makes it a little bit more challenging when you're doing your config. So technically this guy here, if we go to edit style, will be have to be 10.17.19 as well for that to work. And you might say, well, why would you need it to be that? And the answer to the question is E1/2 on both devices are gonna, traffic will come in here to switch 19 or 20 and will take the path that it needs to go. So if PA17 is your primary egress point, for example, traffic will come in this way and go this direction. If Palo 17 were to fail for some reason and be down, then traffic would have to come in this path instead. It would go directly to Palo 18, but whatever config is on this interface right here would end up getting applied over here when the standby device becomes active. So switch 20 and switch 19 would have the same subnet between the two. So that's what you'd have to keep in the back of your mind when you're designing this. So just be aware of those things when you're looking at them. Like I said, I plan on doing an entire series on Palo, so that'll be coming. So it'll just be some time to get that all stood up. So on 20, I'm going to go ahead and I'm going to interface gig 0/0, IP address here will be 10.17.19.19/24. So it'll be the same subnet. And then what I'm going to do is I'm going to, normally the switch 19 and switch 20 would actually be a high availability pair, but they would be in Cisco stack wise. So you wouldn't have to worry about some of this other stuff. So on 17, if we refresh, okay, it's synchronized. Same thing here. It's synchronized, so they're active standby. And if you notice, port 2 is down on this side. And if we look back over here, this is port 2. Port 2 on this side is down. And it won't be working until we actually fail over. So E1/3 would be the same config. So whatever public IP address space we use here would need to mimic that. So if we use, say, 101.17, then we'll go ahead and actually configure that on that interface real quick. So on E1/3, if we give this a layer 3 and we set this to be the virtual router of the default and the security zone of new zone, and we do outside, and we give it an IP address of, say, 101.0.0. Say 78, just for kicks and giggles. And we click on advanced and we do the interface profile. Then we'll be able to apply that, and then we'll commit that config. And then on 25 and 26, they'll get the 101, 25, and 26 respectively. And then if we do that, then what will end up happening is the HSRP VIP, the virtual IP address, will have .1, which is the gateway IP address for the static route we're going to configure on 17. And that will allow us to do the translate, if whatever we NAT internally over to from 10x over to 101, that'll come into play. So I'm going to real quick go to interface gig 0/0. IP address here will be 101.0.0.25. And we'll say the standby 0 is fine because we're dealing with the physical interface. Standby 0 IP will be 101.0.0.1. And then we'll do a priority of, say, 150. And then we're going to say no shut. And then the host name will be R25. On 26, we'll do the same thing. We'll do host name is R26. Interface gig 0/0. IP address here will be 101.0.0.26/24 mask. The IP, the standby 0 IP will be 101.0.0.1, and we'll say no shut because we want router 25 to be the primary. So what we're going to go do is, now that that's set up, we're going to go back to 17. We're going to go over here to virtual routers. Underneath the default VR and on static routes, we're going to create a static route, and we're going to say just default. Destination is going to be all zeros. The interface that we're going to tie that to is going to be E1/3 because that's our outside IP. The next hop is going to be an IP address of 101.0.0.1. The admin distance we'll set as 10. That's fine. Normally I would say turn path monitoring on because you want to ping some public IP address that's beyond your gateway or your gateway IP itself. But your gateway IP is always going to be on. So if, for example, you have, if you try to do a path monitor to 101.0.0.1, it's never going to fail. You're never going to fail over. But that's okay in some cases because the HSRP, if there's a problem northbound of HSRP, so if there's a problem up here, If there's a problem up here, then you want the failover to happen. If there's a failure in here, you want it to be kind of seamless, like where it doesn't matter, because you got to think .1 is right here, and if you ping this IP address consistently, then your static route's always going to be online. But if you ping, say, quad 8 out online, and you're supposed to be going this way, but you end up going this way instead, then does it really make a difference? Technically, no, because it's still highly available. So it's up to you on how you want to do that. I'm not going to do path monitoring for the simple sake that it's just not necessary here. And I'm going to go ahead and click on OK. So that's our default route. Now, what's cool about this is what I would normally do is I would run between 17 and 18 and 19 and 20. I would run some sort of dynamic routing, like OSPF or BGP, typically BGP. And then I would allow traffic to come in to switch 19, and then I would BGP route it wherever I want it to go. So it would give me some flexibility in that respect. So do you have a preference on using HSRP versus BGP OSPF to the upstream routers? So in this case here, when I'm looking at this design specifically, here, I'll bust out my pen tool. Here I am HSRP, because I don't care about this is all public address space. Everything here up is all public. So in that respect, I'm going to be HSRP because .1 is floating between these two. So theoretically speaking, as long as one of these two routers is able to respond to the .1 gateway IP and I'm able to send traffic out to the internet, I don't care. Now, from here up, this section here, public internet, BGP in that situation, unless you've got some service provider that does MPLS that's willing to do OSPF with you, but I've never ran across one. Now down here is where it's a little bit different. You could do either BGP or you could do OSPF. I have a preference. I prefer doing BGP simply for the fact it gives me more route control. That's it. OSPF will get the job done too, right? So you could say on this guy here, do an E2 route and then propagate it down. No, the green box is representing your own address space. So this is you. This is ISP up here. So you would internal routing, your IGP or BGP would be your internal preference. Some folks like to do OSPF internally, some folks like to do BGP. I am of the opinion if you're doing anything like this, you should be doing BGP because then you have more control over the routing. So if you wanted to do AS path prepends or anything like that, you could do it. Is one better than the other? No. I would say it's all about trade-offs. Complexity, comfort is where you would come into play. Anything here in south is what are you comfortable doing? Because me as a consultant, I'm going to talk to you about capability and end state of what you're trying to accomplish. So do I want to make it complicated to the point where you can't support it? No, that is not my goal at all. My goal is to build it so that A, you understand what we're trying to accomplish, B, you're comfortable when I'm done deploying it that you can support it and you understand the design, and then C, when it comes to troubleshooting in the middle of the night or any other things that might come out of the blue that you may have not thought about or we haven't collectively thought about, you're not going to be tripped up by what you're looking at. I want you at 2 o'clock in the morning when you've woken up out of bed because you get a support call, you're able to look at the config, look at the outputs, and you know what you're looking at. I prefer to look at BGP because it's very, very evident when I'm looking at AS path lists and things like that. I'm very, very familiar with that, but that's also because of the fact I've been dealing with it forever. So it's really, what do you, Lawrence, like to deal with? If you prefer OSPF, great, we'd go the OSPF route. It's whatever you want to support. So that's where that would come into play. So all of your natting, all of your ACLs, your security policies, all that type of stuff, that's happening right here. So if you have stuff sitting behind switch 19 or switch 34 that you need to give access to, that's a whole separate set of conversations. I'm talking internal traffic outbound, NATs, things like that. So hopefully that answers your question, but that's essentially how I like to handle it because it's highly available internet edge. Hopefully that made sense. So with that being said, for the simplicity of the deployment, I'm going to go with OSPF between 19 and 17 just because of the fact that it's easy. And I'm going to go to 17. I'm going to go to the default VR, and underneath OSPF, I'm going to click on Enable. I'm going to not reject the default route, and I'm just going to go 17.17.17.17, and I'm going to create an area. It's going to be area 0, and that the interface is going to be 1/2. I'm going to use a point-to-point network type as well. Click on OK, click OK, and click OK. That should be all I need to worry about. And then on the topology, I'll come back over here to the routers, and then on router switch 19, I will go to here. It'll be interface gig 0/0 IP OSPF 1 area 0, and then a network point to point. So I should form an OSPF adjacency here momentarily with that. And once I do, I should be able to, let's go back over to 17. I forgot to do one thing. Underneath the redistribution profile, I'm going to create a redistribution profile. I'm going to say redist. I'm going to allow redist with a priority of 1. And I'm going to say that the source type is static, and that the interface, actually I don't need to do anything with that. I think I should be okay. No, we're going to say delete that. I think I should be okay with just that. And then click on OK. And then underneath OSPF, underneath export rules, allowed that, and I should be able to pull in, redistribution, and we'll click on OK. And then we're going to commit that. So now that I've done my job here, exactly. That's exactly what we're doing. We're simulating a normal DIA connection. Oh, you know why? Because I'd never hit commit on the OSPF adjacency. That's why. So there it goes. So with that being said, if I do a show IP route, I should have, I might need to take this a step further. Redistribute, show IP OSPF database. Okay. There's the default. So I have my default route via OSPF now. And so now it would be a matter of, I have to do a NAT rule and I have to do a security rule. But if I go up to router 25 and 26 respectively, if I look at the show standby brief, I have an active connection. Everybody's good to go. So now what I'm going to do is I'm going to bring up 23. In the interest of time, I'm going to bring that up. And I'm going to do a BGP peering between these two. This is literally what I did for a customer about a year ago now. And they learned a lot. They were surprised. So I'm going to say router BGP, and for the simplicity, I'm going to do 25. I'll type in neighbor of 25.0.0. Actually, no, let's do 23.25.0.25. And remote AS of 23. And we're going to go to interface gig 0/1. IP address here will be 23.25.0.25. We're going to no shut that. And then on 23, once he's booted up, That'll take a minute. And in the meantime, while I'm doing that, I'm going to go do the NAT rules. So over here on policies, I'm first going to do the NAT. So on the NAT here, I'm just going to call this inside to outside NAT. And then the original packet, the source zone is going to be the inside, the destination zone is going to be the outside, and the translated packet is going to be a dynamic IP import. The translated address is going to be the interface address. Interface address is going to be E1/3. The IP address is going to be that IP. Fairly straightforward stuff. I'm going to click on OK. And then I have to create a security policy for it. So I'm going to add a security policy. I'm going to call this inside to outside NAT policy. Universal is fine. The source zone is, you guessed it, inside. The destination is going to be, you guessed it, the outside. The application is going to be everything. The service and URL category, everything. And we're going to log everything. Why not, right? We're going to click on OK, and then I'm going to go ahead and commit that. So if I jump back over here to the topology, and I go to router 23, go to no, give that a minute. So while we're waiting for Palo 17 to do its thing and push that config, we're going to wait for router 23 to finish doing his ICD, and then we're going to do a quick BGP peering. We're going to advertise a default route, and this will simulate down to the letter what it is for a customer that I did. Host name is going to be R23. The signing hasn't happened yet. That'll take just a minute. And we're going to say router BGP 23, neighbor of 23.25.0.23, remote AS of 25. And we're going to do a default dash information originate. And we're going to do an IP route, quad 0 route to null 0. So interface gig 0/0, IP address here of 23.25.0.23/24 mask, and we're going to no shut that. Did I put in a change before this activity? Yes, and it was all approved by me. Oh, I did something wrong. Uh, 23, yep, that's what I put in. Do show run section BGP. That's right. Can I ping it? Do ping 23.25.0.25. Okay, it talks. Just waiting for the BGP peering to come online. Oh, whoops. I see what I did wrong. I goofed. I need to say .23. And 23 needs to point to, yep, I have them backwards. So this is what happens when you're going too fast and you don't have things laid out correctly. It makes silly mistakes. But once that's in place, we should be good to go. There's BGP, and 25 should have a default route via BGP. Show BGP IPv4 unicast. Summary. I might need to do the network statement. Let's see, a do show IP route here. I have a null 0 route, do show BGP IPv4 unicast. Okay, do show, I should be able to do show run section BGP. Default information originated apparently isn't good enough. So we'll just do a network of quad 0. That should be enough. show IPBGP, just another variation of what I just threw out there. That's being propagated. I hit the up arrow. The route's being learned. Now I have a default. All right, so now that everything's been done and applied, the question is, ladies and gentlemen, should I be able to ping, let's see here, can we ping, before we do any internal testing, let's do a quick internal test. Can we ping from 25, can we ping, let me just show ARP real quick, ping 101.0.0.78. You know what, that's not going to work because I didn't enable the, did I do the interface profile on 3? I think I did. Yes, I should be able to ping 101.0.78. So if I ping 101.0.0.78, okay, beautiful. So that was my main fear, would be that 21 and 22 weren't sending traffic, but they are sending traffic. So I didn't do any config on 24, switch 21 or switch 22. They're VLAN 1 all across the board, everything's good to go. I would never do that in production, but for a lab, nobody cares. So the question is, if I go to switch 19 and I try to ping, let's 23.25.0.23. So if I try to ping 23.25.0.23, can I ping it? I'm trying to ping from the inside, right? And it is sending traffic up to Palo 17. So let's go over here to monitor and let's see what the deal is. So that did not go through. So let's do a repeat of 100. And I'm going to drag this off screen. We're going to do a... Actually, I need to go down here to session browser. Okay, so we do see the inside, the ping going through. It looks like it's supposed to be working. Now the question is, can 23 ping, let's see, what do we want to do? We want to do a ping of what? 23.0. No, I want to ping 101.0.0.78. So, what did we forget to do? What did I talk about earlier? Some of you weren't here for the troubleshooting I was doing earlier, but what am I not doing from 25 to 23? I'm not advertising the subnet that's in here, right? The 101/24. 23 doesn't know anything about it. So the internet routing table is just like, good, you know, whatever, dude. Like, it's not going to work. So what we have to do on 25 is what? Show run section BGP. We have to come up here, router BGP 25, and say network of 101.0.0.0 mask/24. Now 23 will get that. Show IP BGP. We see the subnet now, and if we go back to switch 19, the ping started to work. So if we try to ping that again, the ping goes through, and if we refresh, we have a table full of responses. So that's what we were doing wrong. Well, I shouldn't say we. It's me doing all the configuration, but the reachability wasn't there. So just some things to keep in the back of your mind when you're looking at connectivity. So just because of the fact that I like to always take my testing one step further, because that's just how I am. What I'm going to do is on 23, I'm going to go up here, type in username is admin with a privilege level of 15 and a password of admin. I'm going to say line VTY 0/4, login is local, and the transport input is telnet. I know, super secure. But now I'm going to do a telnet to 23.25.0.23, and I'm going to type in admin, and if I go back over here to the Palo and I refresh, I should have a telnet connection going outbound, and it's allowed. So there you have it, ladies and gentlemen. Connectivity up in place. So let's recap what we've done. considering I ran into some hardware issues and I had to reboot my server. So what we did, and let me change this to be black so that it's a little easier for you guys to see. What we did is we put these guys in high availability mode. This guy right here is the active guy. This guy right here is passive. We have an HA1 link here. We are running OSPF here. We have a default route being propagated down to switch 19 where we have this interface configured. We are doing both our NAT and a security policy to allow traffic from the inside zone outbound. We have the 101.0.0/24 subnet applied. .78 is applied here. We've got .1 up here is the VIP. We got HSRP running here between these guys. And there's a EBGP peering running between 23 and 25, where 23 is advertising a 23 is advertising a default route. Uh-oh. I hate when it does that, because then all of a sudden it starts to freak out. It does this whenever I... Okay, so we'll just... Yeah, it's being stupid. We got that, and then we advertised this subnet into BGP on 25, and then 23 was able to get it, and so now we're able to do our NATs, we're able to get out to the internet, and all that type of stuff. It's a very, very basic deployment. When you think about it at the grand scheme of things, it's a very basic deployment. Do we have a lot of moving parts? Sure. But this is where you have to, if you're just a network guy, if you're like me, and you spend a lot of time routing and switching, the concepts are the concepts, right? You understand how OSPF works, you understand how BGP works, not to the CCIE level, but to a CCNA level, right? You don't have to know this stuff heavily or be super in-depth on knowledge on OSPF or BGP to make any of the basic stuff work. Basic adjacency, basic peering, basic route advertisement. If you understand those things, in most networks you're going to be okay. Where diving into the palos and understanding how to get them to work, or whether it's ASA or Checkpoint or Fortinet, all of those same platforms, which basically anything in the Gartner Magic Quadrant you should be at least generally familiar with from an operational perspective. And I would include, what else is out there? There's SonicWall, pfSense. I'm trying to think of what else is out there. FTD, you should be at least generally familiar with all the platforms that are out there, because you never know what you're going to walk into, especially coming from a consulting background. So with that being said, the benefit here is if 25 or 26, they're both internet edge routers, if either one of them were to die, it doesn't matter because they share the VIP between them, so they'll always be active, or one of them will always be an active forwarder, and so regardless of which internet connection you go with, you should have no problem getting out to the internet. And so the particular customer that I'm mimicking here, they actually had they had me set it up to where they could fail over this way, and it would stay that way. If they wanted to fail back, it was a manual process. So this way here, the first way was automatic. But if they wanted to fail back, this was a manual process. They literally had to go to the interface level, set the priority higher to trigger the preemption to come back, and then they had to remove config. And I gave them like a whole walkthrough, and I demoed it in a lab. Basically, what you see on my screen is essentially what I stood up for them in a lab and walked them through the process so that they would have what they were looking for and got it all working. Was it difficult? Not really. Once we understood the gist of what they were trying to do, it was fairly simple to set up. But there's lots of different ways to do this, right? It doesn't have to be Palo. I happen to really like Palo. Ever since I started working with it, probably 5 or 6 years ago, I prefer this over ASA or FTD any day of the week, only because of the fact that I think it's a better platform. But that doesn't really matter what my opinion is on it, but I have to know ASA, I have to know FTD, I have to know checkpoint. I'm actually starting to learn that more in depth. I have to know Fortinet. So it's, well, I don't have to know. I choose to know so that when I walk into an environment as a network architect, I can like, oh, okay, cool. I'm generally familiar with what they've got going on and how they're stood up. But the cool thing about it is if you understand basic routing, basic switching, basic routing, basic firewall policies, NAT, security, traffic in, traffic out, those things, a high level VPN, whether it's remote access or site to site. Now that I'm actually talking about all this stuff out loud, I probably should put together kind of a networking basics course that covers all the big things that you might see in the networking space, firewalls included, just as a high level. Nothing seriously deep. We take a general network diagram, we build it out with best practices and the common things that you're going to see in the real world. Because what you see on my screen, I've ran into probably 150 customers that have this identical type of design because it's highly available, it's redundant, it's resilient, it works. It's a best practice edge design. Now you could take this platform right here. These could be Aruba switches. These firewalls here could be Fortinet, or they could be Checkpoint, or they could be ASA. It really doesn't matter. They all do basically the same thing. So at the end of the day, that's where you really got to keep in the back of your mind, what am I walking into? But once you understand the design, and you can just kind of glue in whatever technology or capability you want. Like I was saying earlier, do you feel more comfortable with OSPF than BGP? Great, go the OSPF route. I would prefer doing BGP because it gives me more flexibility. So, but it's, you like one way, I like the other. Neither one of us are wrong. It's just a matter of going a particular direction. So, I'm looking for a good Visio course for network engineers. Any suggestions? It's actually a good point. I hadn't thought of that. Are you looking for something specific for Visio, or like how do you add stuffed templates to Visio that are the actual template or the icons that the vendor puts out there? Like, do you have any specifics, or just a general, this is how Visio works, how you would export, move to a PDF, rename things, work with the connectors? Like, do you have anything specific that you would want to know? Because I don't claim to be a Visio expert. I'm proficient in it because I work with it every day. So I'd be curious to know exactly what you're looking for, because potentially I could build something out for that and put like a little mini series of content together for that. Because I don't think I have Visio on this computer. Because Visio is kind of expensive. I don't think it's on this one. But I could do something with like Draw.io. Yeah, Visio, I don't have Visio on this machine. But hopefully everything I've talked about so far makes sense. The other one you could check out would be Draw.io. Yeah, so decide later. So this is Draw.io. I've used this a lot for my when I was doing a lot of my VMware NSX content, because it gives you a Visio-like platform to work with. So for example, if you come down here to advanced, you can actually do other stuff too. You can yeah, I do agree with you, Lawrence. That is a very big thing. Doing good diagrams is good, and then learning how to differentiate. So I'll give you a great example of what I mean. So I can network. So let's see here, more results. So for example, they have... Well, I got some VMware stuff in here too. That's kind of cool. Flow logs, internet gateway, router. All right, so we'll take a router. Yeah, Kenneth, you're right. The Palos have a default route pointing to the virtual IP of the HSRP. You are correct. So I'm trying to find a switch. Everything they have up here so far is I don't see anything for a switch. A lot of more results. That's cute. Not a sync. That's a local network gateway. Virtual router. That's cute. They don't have anything for switches? Oh, here we go. Finally. It only took me like, what? How long? Alright, so you have your layer 2 network. And we'll make this a little bit bigger. So we have this right here. So you need to identify a layer 3 device versus a layer 2 device and how you would connect these two together, right? So I'm not going to worry about the ends of the connection. But for example, if you take, let's do this cloud up here at the top. And we'll do another router over here. And then we'll take this switch and we'll put it over here. And then we'll mimic this like that. And then what we're going to do is we're going to draw a connection to him. We'll draw a connection to him. To him. And then we'll just get all these connections squared away. And so we'll come in here. We'll just do internet. And then you can do like a dotted line. And this dotted line could be from here to here. And then we can do another one to here. Let me put this right here. And then we'll do one more. And this guy could go to here. And what you can do is you could take and then you could overlay VPN on top of that. So now what you'd be able to do is take this information, and this diagram is very, very basic, but what does it convey though? If you add some IP addressing and some other stuff, what does this convey? Right? It conveys that, you know, you got some networking stuff here and some other operational stuff. You got some VPN set up between your routers. There's a layer 2 network somewhere behind the scenes, stuff like that. So it doesn't take much, right, in order to convey what's going on. But if I was, it would take me 5 minutes to do this, but I do it every day. I'm very, very comfortable doing it. So these are some things where you've automatically added layer 2, layer 3, and some logical connectivity. And for example, let's say you wanted to take this a step further. VPC. So let's say you have an Amazon. Oh, it didn't like that. You have an Amazon instantiation. There we go. And let's say you've got Amazon attached here. And you've got, where I saw Route 53 somewhere. One of these places. Network. I guess not. Anyway, not that important. So what I'll do is I'll take this connection here, I'll plug it into this guy, and then we'll take this and we will repurpose it here. and we will add a VPN connection to here. And the idea would be that we have Amazon connectivity as well. So not only do we have VPN connections to all of our remote sites, we also have an Amazon instantiation up in a VPC and the connectivity that goes along with that. So we have the ability to control. Oh, there was Route 53. So I'm not sure why they used that logo. I'm not sure if that's a legit one or not. But as you can see, we have, just by doing this little bit of diagramming, you're able to convey, you have 3 sites, all VPNs between them, and then you have an Amazon instantiation, and then you'd be able to break into subnets. And what you would do is you would take this and you would have like site 1, and you'd have a picture for site 1, and you would dig into the details of what site 1's got. Same thing with site 2, site 3, site 4, whatever it is. So it would be much easier to dig into your environment and show this than it would be to sit there and try to describe it. For logical L3 diagrams, 90% of the time I start with just the blank boxes with L3 switch or router in it, and only add the L3. Make it pretty comes after understanding. What exactly? I completely agree with you. I typically will do the exact same thing. So what he's describing is this. I will take a rectangle, and let me just bring this down here. I can do the exact same thing that I just did. So we take this, and we draw it together, and we take our cloud, right? And then we're able to come in here, and we'll do L3 switch. We'll do internet. And, L3 switch, so on and so forth. And then you just draw the connectivity wherever you need it, right? You build it out like so, and then as you're going along, and once you have everything mapped out, you can then circle back and focus on making it look more like this. This is a little prettier than just boxes with letters inside of it, but this drives the point home, right? This is easier to deploy. If you wanted the big picture very, very quickly, you can look at this and discern what's happening. But for people that need pretty pictures or icons and things like that, you could either redraw it, or you can selectively pull out this and replace it with this and get the job done. So that's essentially what Lawrence is referring to. And ironically, that's how I do 90% of my diagramming. I start out with a very loose. It's usually I draw a circle with a plus sign in the middle of it, and then a switch is just I don't go 4 arrows. I do one arrow one way and one arrow the other way. That's a switch to me. I draw connections, and I'm able to build off of that. Then I'm like, okay, what platform is that? Oh, that's an Aruba switch, or it's a Cisco CAT switch, or it's a Cisco Nexus 9K, or whatever the platform it might be. I can then dig into those details later on. So, but that's what really helps me. But Draw IO, it's free, right? So you can diagram whatever you want out for free, and then build out. You can save this too. If I wanted to save it somewhere, I could, and I'd be able to render it and provide context wherever I'm going with it. So hopefully that makes sense, and it might be something useful for you. If not, oh well. I don't take it personally that you don't use my guidance, but since you asked, I'm going to try to provide you a little bit of clarification. And there's other platforms out there too, but Draw IO is a free diagramming tool. So if you can get away with free, why wouldn't you? So, but that's pretty much it. That's all I really wanted to cover in this video, or I should say in this session. This is not be a really long video, but I didn't expect it to go almost 2 hours, but once I got into it, I figured I might as well just finish. And then spend hours working out how to lay it on the page to make it fit. You know what? You are so right. Actually, it's funny you say that, because I was just doing that the other day, where I had this rather robust diagram that I built out in this style right here. I did this, and I got it all laid out. And then when I started adding in the subnetting, I started adding in all the logical pieces to it. I actually created new. I had layers 1, 2, and 3 built out in different pages, and then I had a full one laid out where it was layers 1, 2, 3, and then all logical stuff like where the load balancers were, firewalls, VPNs, all that type of stuff to try to build a full picture. I mean, it took me a solid day and a half to put it all together. But once I had it all put together and laid it all out, the the reactions I got from when I delivered the design were like, wow, that's really cool. But it took me probably the better part of 16 hours to do it all out. I mean, it wasn't super complicated. It was basically about this size right here, maybe a little bit bigger, 20 or 25 boxes. But once you start putting all the connections together, that's when it really gets interesting. Just wondering if you use Draw.io to build an accounts network. No, I've never had to do that. I have used Lucidchart, which is another option here. Lucidchart. So Lucidchart does basically the same thing that Draw.io does, but it's free. Draw.io is free, where Lucidchart requires you to sign up. And I spend a lot of time doing work in Lucidchart. Lucidchart is a web-based thing, just like Visio can be, but I just, I've worked a lot with that one. So, but if you want free, Draw.io does a good job. So, but Lucidchart does the exact same thing. It's just you had to pay for it. So, but anyway, it's getting close to 9 o'clock here. I would like to go and I didn't plan on being on this long, but since we're here, it is what it is. So I'm going to cut you guys loose, and I will go ahead and I'm going to go work out and try to figure out some of the networking stuff from my the Encore and an RC series workbook topology, and figure out. So I have some validation and verification stuff that I have to work through. So, but yeah, other than that, guys, that's pretty much it for tonight. I will see all of you next Wednesday. As long as I don't have anything on my calendar, I should be able to do it that day. There's been a couple of minor changes in the job role that might require me to be a little bit busier, but I think I should be okay. But other than that, yeah, I will catch all of you guys next Wednesday for the next Whiteboard Wednesday. And then I've moved the coaching sessions to Monday because Friday just wasn't working out for me anymore. So I will be going there instead. Yes, I will be at Cisco Live. Will be flying out the 1st, and I have a session Sunday, and then I will be there Monday through Thursday. So yes, I will be at Live. So looking forward to it. It's what 2.5 weeks away. Let's see, 1, 2, yeah, 2.5 weeks. Yeah, no worries, Ken. Glad you were able to hang out, and we were able to chit chat for a little bit. So yeah, good stuff. I will catch all of you guys next Wednesday. So you guys have a good night. Stay safe out there. If you guys have any questions or whatever, don't forget to drop a comment on a video or what have you, and I will see what I can do to help you out. So with that being said, you guys have a good night, and I'll catch you guys next week.